HOD. I had to go to IDE. They are supposed to. They are connecting in that room or otherwise. 15 minutes is gone.
Okay, sir. It is started. Again, problem.
They should have some timing.
Already the streaming started. Thank you. Start ही हो गया ना? Okay. Yeah. Thank you. Good afternoon. Yeah, I think there was some problem in yesterday's class. I took the class, but it was not streamed, so I'll repeat the class again today. Just give me 2 minutes to check my to download my presentation again from my laptop, my email, because this is another place. Yeah. So yesterday I took the class. Yeah, yesterday I took the class on averages, mean, median, mode, and measurements of dispersion. Measurement of dispersion I have already taken briefly earlier, and let's discuss about averages. So statistics means it is a mathematical science. Statistics is a mathematical science pertaining to the collection, analysis, interpretation, or explanation of presentation of data. Statistics is a mathematical science pertaining to the collection, analysis, interpretation, or explanation and presentation of data. So what do we do with statistics? Statistics we do. So these are revision class. I will be little fast in discussing averages and central tendencies. So it is a mathematical science. So what do? We collect the data, we analyze the data, we interpret the data, and whatever information is coming out from the data in text form or in logical forms, we present it in the form of explanation. So we explain the data and we present the data in an explainable form. So it is a mathematical science pertaining to the collection, analysis, interpretation, and explanation and presentation of the data. Now the central value. A couple of things, a couple of examples I may skip here, but yeah. So central value is very important to understand in statistics, because you can get different types of data in which the continuous variable, there are something known as continuous variable, categorical variables. So these are the two broad categories here. So two types of data, like categorical data is usually in a yes and no manner. Like for example, a disease present or a disease absent. Like hypertension present, hypertension absent. If you have this kind of data, that is a categorical data. If you have a blood pressure, like for example blood pressure, systolic blood pressure or diastolic blood pressure, it is a continuous variable. Each and every person will have a different blood pressure readings. So there will be, if you consider blood pressure or hemoglobin is a continuous type of data. And if you consider anemia versus hemoglobin, anemia present, anemia absent is categorical type of data. So central values and averages are usually done for continuous type of variables. So those continuous variables, means, median, mode are the averages. Okay, we will read it. We will study about this. But you already have, somebody already have taken the class for you. This is a revision class. I'm just covering it in brief. Now uses, to find whether normal value lie close to it. Okay, uses of central value are to find whether normal value lie close to it, or it is too small or large, present in both the ends. Okay, now uses of the data is to find out whether the normal value lie closer to it, or it is too small or large when presented at the both, the large value which is presented at the both ends. Now to find which group is better off by comparing between the two groups. So individual value as well as the group values. For example, incubation period of cholera versus typhoid, okay, is less than typhoid. Averages. When we talk about averages, there are three types we calculate. There are three types of averages in statistics. There is mean, median, and mode. Mean, median, and mode. Okay, we'll talk about this briefly. Just a second. So what is mean? It is arithmetic. Arithmetic means it is obtained by summing up of all the observations by number of observations, and it is denoted by x bar. That is arithmetic mean. Okay, what is the mean? What is the meaning of mean? It is the mean. It is the value which is obtained by summing up of all the observations by number of observations. Okay. So for example, you have 10 patients and you have 10 hemoglobin values of 10 patients. Somebody will have 11, somebody will have 12, 13, 14, like this, or 10. So mean will be calculated as, you have to add up all 10, 11, 12, 13. Each value you have to add up each value and divide it by 10, because you have 10 number of patients. So summing up all the values of the reading divided by the number of people or number of participants or number of patients in the data it is denoted by x bar. Mean. Now there is sample mean and there is a population mean. So the formula are given down below. It's the same formula which I was talking about. So arithmetic mean of the data value, there are two types of mean. Sample mean means each person sample, each person's mean, and then there is a population mean. So if you draw sample from the from certain population, and when you calculate that mean, it is known as sample mean. And when you want to see the value where it stands from the population mean, you have to calculate the entire population's mean. Okay. The most common measure of mean is the most common measure of central tendency. The most common measure of central tendency is mean. It is used most commonly. It acts as balance point. It acts as a balance point which can be affected by extreme values. Those are known as outliers. So there are the three characteristics which are very important to know. The most common measure of central tendency is mean. It acts as a balance point and it is affected by extreme values, that is outliers. So outliers are those values which are far away from the mean, and those are the extreme values on the negative side or on the positive side. So if you see the example here, just a minute. If you see example here, these are the measured values. If, for example, these are the measured values, okay, and if measured values are almost equally distributed and it is normally distributed, the mean is coming out to be 5 here. So these are the number of values, and this is what. And if on the scale of 0 to 10. Now, in this example, on the scale of 0 to 10, most of the values are distributed normally, and one value is standing out on 14. So that this is giving us a value of 14. So this is known as outlier. Now, if the outlier shifts to the positive side, the mean also shifts to the positive side. So now here, if we calculate from the same data, the mean is around 6, and here the mean was coming around 5. Okay. Now, what are the advantages? Advantages of mean are there is only one mean for a data set. The uses are all information in the data set. There is only one mean for the data set. The mean uses all the information in the data set. It is easy to manipulate mathematically and it is easy to understand. Now, on the disadvantageous side, it is influenced by extreme values which are outliers. Like, for example, if Bill Gates moves into any neighborhood, then the average income of the family would increase dramatically beyond what it was previously. Right? And other disadvantages, it may be sometimes ridiculous. It may be sometimes ridiculous because you may get some value which is mathematically right, doesn't make sense. Like, for example, average number of children. How can average number of children be 4.5 or 4.7 or 4.76? Either it will be 4 or it will be 5 or it will be 6. It will be in whole numbers, right? So sometimes you get this kind of value in mean. Okay. Now calculation of mean, again, it's ungrouped series and group series. There are ungrouped series and group series. Two ways you can calculate the mean. If the number of observation is small and you take two groups like direct and indirect, the choice depends on the size of observation. So in direct, the formula will be summation divided by number of observations. Okay, like for example, tuberculin test of 10 boys is given in ascending order. Find the mean size of reaction. Okay, so this is an example. The results of tuberculin test for 10 big boys are given here: 3, 5, 7, 7, 8, 8, 9, 10, 11, 12. The answer will be mean is equal to summation of all the values divided by 10. So it will come around 8. Now when there is a size, when the size of the observation is large, the assumption ability arbitrary mean or working origin mu will be I think this I'll skip. Okay. If number of observation is large, the procedure will be the data arranged in a groups and frequency distribution table and should be prepared first. Then find values of each group separately and multiply the mid value of each group with frequency. Then add up these product values and divide by number of values. This is known as weighted mean or grand mean or means of the means. Okay. So in the group series, there are two groups, like for example, your batch versus other batch, and you're measuring the scores of two batches. The data should be arranged in group or frequency distribution table first, then find values of each group separately, then multiply the mid value of each group with frequency and add up these products values and divide by number of values. This is weighted mean, grand mean or means of the mean. Here is the calculation how to do that. To find out arithmetic mean of this number, the arithmetic mean of this number will be divided by 7, or summation divided by 7, that will be 2. In this case, there are 2 1s and 3 2s and 3 3s. The number of times each number occurs is called its frequency. This can be clearly given by the table below. So here is the table, right? And then you multiply the number into the frequency, and then the frequency is calculated here. So step 1 is find summation f. Summation f remains same. Step 2, now find summation fx, then you get the number. And step 3, now substitute in the above formula, which is 14 by 7. The arithmetic mean is equal to 14 by 7. Class interval arithmetic mean definition. I'll skip this because usually it doesn't come here in your class. Coming to median. Median is the value of middle observation after placing the observation in either ascending or descending order. Half the value lies above it and half the value lies below it. It is the value of midpoint, middle observation after placing the observation in either ascending or descending order. How the values lie above it and how the values lie below it. Now coming to the median, the robust measure of central tendency is the median is the robust measure of central tendency. Okay, it is not affected by extreme values. So these two characteristics of median are: it is a robust measure of central tendency and it is not affected by extreme values. Those are outliers. Okay. Now, if you see median, if you see in this example, the median is 5. What you have to do, you have to arrange the number in ascending order or descending order, and then take the midpoint of it. So in this 1 to 9, if you see, even if it is normally distributed, the number median is 5. And even if it is not normally distributed, there are some outliers like 14 and 1. You will get the median number as 5 only. In an order array, the median is the middle number. In an order array, the median is the middle number. If number or number, like number of sample, number of people in sample, or number of people in the population is odd, the median is the middle number. If n, or number of people or number of population, is even in even numbers, the median is the average of the two middle numbers. Understood? So if those are even numbers, you will get two middle numbers, and then you have to take an average of two middle numbers, right? So in ungrouped series, if the number of observation is odd, then the median of the data will be n plus 1 by 2 observation. Even, and if it is even, then the median of the data will be the average number of n by 2 and n by 2 plus 1. Okay. Count the total number of given. There are okay. These are the same examples. I'm just skipping it. Okay. In group series, simply divide the total observation by 2. Okay. In group series, the observations are supposed to be divided by 2. Okay. Yeah, if the number of observations are 200, then the median will be 100th observation. If the number of observation is 201, then the median will be 101st observation. Advantages of median are there will be only one median for a given data set, and it is unaffected by the extreme value. The disadvantages on the downside are it doesn't take into consideration all the observations. So it doesn't take into consideration all the observations. Median is better than mean in case where there are extreme values in the given data sets. For example, income of 5 individuals in a survey is 500, 100, 150 and 2000. Here the mean is 480, but the median is only 100. Okay, so it is not taking the entire all the values into the consideration. Coming to mode, mode is a measure of central tendency, value that occurs most often. Okay, it is a measure of central tendency. It is a value that occurs most often. And it is not affected by extreme value again. It is used for either numerical or categorical data. It is used for either numerical or categorical data. I told you the categorical data right in the beginning. Okay. So there may be no mode or several modes. So the mode is equal. Okay. So in this example, if you see value number 1, value at number 3 is only coming only one time, but value 5 is coming 2 times here, and value 9 is coming 3 times. Value 12 is coming 2 times, 10 is coming one time. So if you see what will be the mode? Mode will be 9. Okay, it is driven by the number of values coming repeatedly in the data set or in the variable information. So that is mode. And if the distribution is normal, here there is no mode, means all the values are coming only one time, or all the values are coming only at the equal numbers. So there is no mode here. The properties, there could be more than one mode for a given data set. It is unaffected by extreme values. It does not use all the observations in the given data set. Right. Now mean, median, mode, which is the best? Which should you be using it? And now that completely depends on the data set. What kind of data do you have? Okay, so the mean is generally the first choice. People use mean as a first choice because it uses all the data sets. So mean is generally the first choice. When the following scenario occurs, the median is the best choice. Now, following scenario means there is a extreme observations. If there are extreme observation outliers, then median is the best choice. And if there is a if there is a determine the rank of a particular value relative to the data set. If you want to determine the rank of the particular value relative to the data set, then you should use median. The mode is the rare and the best measure. The mode is used rarely, but it's the best measure. Now, talking about relationship between mean, median, mode. It is symmetrical distribution. It is simply So there can be symmetric distribution, there can be skewed distribution, or there can be skewed distribution on the right hand side, or there can be skewed distribution on the left hand side. So in symmetric distribution, you will see mean, median, mode are the same. If the distribution is normally the data is normally distributed, then the mean, median, mode are the same. If the data is skewed to the right side, the mean is larger than the median. If it is on the right side, the mean is larger than the median. And if it is skewed on the left side, the mean is smaller than the median. So if you see in this graph, if a distribution is symmetrical, the mean, median, mode may coincide. They are all same. This is the mean, median, mode. if the data is skewed on the left side, you see the mean is smaller, mode is bigger, and median is okay, similar. And if it is skewed on the right hand side, the mean is mean, median, mode. Okay, mean it should be small. I think there is some error here. Right, the value of mean should be smaller, right? Okay, thank you for today. This was a repeat class from yesterday. So yesterday's class was not streamed because of some errors, some technical problems. So I repeated this class. We will continue our next class again, and then we will see what are the other topics left for revision, and then we'll conclude. Thank you.